1961. A physicist seals his friend inside a room with a single photon detector, then stands outside the closed door and asks himself a question nobody had a good answer to. It took until 2019 for anyone to actually build a version of that room and test it for real. That's one investigation. There are 4 more like it. A misquotation about a Nobel laureate that outlived him by 60 years and counting. A French physicist who spent decades arguing that reality itself wears a veil. A Sanskrit word for sustained attention that turned out to describe a real, measurable effect. And, near the end of this one, a theorem born from someone's failed attempt to build a machine that could send signals faster than light. 5 investigations. One question asked 5 different ways. What actually happens in the gap between one measurement and the next? It sounds like a small question. It isn't. Each of these results followed from someone refusing to accept the easy, comfortable answer to it. Physics does not yet have one agreed answer to this question. What it has, after 5 separate investigations, is 5 precise constraints on what any answer would have to look like. Physicists describe an isolated quantum system in that gap as existing in a superposition, several possible outcomes held at once in the mathematics, none of them yet settled. Left alone, a system doesn't have to commit to one outcome. Something has to force the question. What forces the question turns out to be one of the hardest problems in physics, not because the equations are unclear, because the popular explanations of what those equations mean have drifted so far from what physicists actually established. This is the story of 5 attempts to close that gap properly, what each one actually found, what each one does not claim, and a set of much older investigations, working in a completely different territory, that keep landing on a strikingly similar shape. Start with the myth everyone repeats. Consciousness causes collapse, the idea that a measurement only becomes real once a conscious mind looks at it. Niels Bohr never said that. What Bohr actually argued, across decades of correspondence and lectures, was narrower and stranger. A measurement is an uncontrollable physical interaction between a quantum system and a classical apparatus. Consciousness plays no special role. The interaction itself is what matters. Bohr held this position across years of disagreement with Einstein, most famously at the 1927 Solvay conference and later over the EPR paper. Einstein wanted a version of reality that didn't depend on how or whether it was examined. Neither man ever conceded the point. By the 1970s and 80s, physicists led by Wojciech Zurek had a mechanism for how Bohr's position actually works, without ever invoking a mind: decoherence. A quantum system, left in contact with its environment, rapidly loses the ability to show interference between its possible outcomes. Zurek went further, showing which properties survive this process and become the stable, classical-looking ones. He later called this einselection, though the term itself came into use gradually over the following decade, not because someone looked, because the system interacted with almost everything around it, continuously, and only certain patterns survived that interaction intact. Eugene Wigner himself once argued for a version of the consciousness view. By the 1970s and 80s, he'd moved away from it. A 2011 survey of physicists and philosophers found only a small fraction still holding it. It persists in popular science. In physics itself, it's now a fringe position. Roughly 1800 years earlier, a Buddhist philosopher named Nagarjuna had been investigating a related question in a completely different vocabulary. Not what triggers a measurement, what it even means for something to have a fixed, independent nature at all. His answer, dependent origination, held that nothing possesses a nature of its own, separate from what it depends on and interacts with, not empty in the sense of absent. Empty in the sense of never standing alone. Nagarjuna never addressed quantum mechanics. There's no published record of Bohr or Zurich ever engaging in this text. But notice the shape of both investigations refused. Neither accepted that a thing simply has its properties, sitting there, waiting to be noticed. Both insisted the interaction is where the answer actually lives. Investigation 2 starts with a stranger question. What if the person doing the measuring is themselves inside a quantum system? In 1961, the physicist Eugene Wigner proposed a thought experiment. Seal a friend inside a room with a single photon detector. The friend measures a flash, or doesn't. From the friend's perspective, it's settled immediately. But from Wigner's perspective, standing outside, unopened, the whole room, friend included, is still described as a superposition. Two people, one event, both, according to mathematics, correct. A different physicist, John Wheeler, later used dramatic language of his own, writing of a participatory universe where observation plays a genuine role in what counts as real. That's Wheeler's phrase, not Wigner's, a separate, carefully argued philosophical position, not a claim about this specific thought experiment. Wigner's own position was narrower and stranger still, that a measurement only completes once its result enters a conscious mind. For decades, the sealed room experiment stayed a thought experiment. In 2019, a team led by Massimiliano Proietti actually built a version of it, using 6 entangled photons standing in for 2 separate observer and friend pairs. The result violated a specific inequality by 5 standard deviations. Here's precisely what that means. If you hold onto 2 reasonable assumptions, locality and free choice, the 2 observers' facts cannot both be treated as one single, shared, observer-independent story. It does not mean consciousness creates reality. It means something narrower and just as strange. 2 consistent accounts of the same event, neither one simply wrong. Well over a millennium before Wigner wrote his thought experiment, a short Sanskrit text had already pointed towards something adjacent, not another observer, competing for the correct account, something underneath all such accounts entirely. The Mandukya Upanishad names 3 ordinary states: waking, dreaming, deep, dreamless sleep, each one complete, each one convincing, each one presenting a different picture of what's real. Then it names a 4th, Turiya, not one more perspective in the list, what the text describes as the ground beneath all 3, never itself contradicted by any of them. The text is not solving Wigner's problem. It was never trying to, but both investigations refuse the same simple comfort, that there's one final, complete account sitting above the whole scene, available to whoever looks correctly. Investigation 3 asks the most direct version of the question yet: is the unmeasured world even real? And if it is it the same world for everyone? A French theoretical physicist named Bernard d'Espagnat spent much of his career on exactly this. Working at the same laboratory as Alain Aspect in the early 1980s, d'Espagnat drew directly on Aspect's experimental confirmations that Bell's theorem holds. Entangled particles, measured at a distance from each other, really do show correlations no local, classical picture can explain. D'Espagnat drew a specific technical distinction from this. Standard quantum mechanics, he argued, is only weakly objective. Its statements are valid for everyone, but describe operations of measurement, not a mind-independent world directly. He proposed something he called open realism, a way of holding onto a real world beneath our measurements without claiming direct, total access to it. From this, d'Espagnat drew a careful, specific conclusion. What physics actually describes, he argued, is empirical reality, the reality we can actually test. Beyond that lies something he termed veiled reality, not unreal, simply never directly, unfilteredly accessible. So did d'Espagnat arrive here through some contemplative tradition, the way other physicists in this series did? No. By at least one documented account of his work, this conclusion came entirely from within physics and Western philosophy. He wasn't echoing anyone. He arrived here on his own terms, working the problem from the inside. In 2009, the Templeton Prize recognized this work, explicitly for acknowledging that science may never fully explain the nature of being, not a failure of physics, a finding it. Investigation 4 turns from what's real to what stays in place. In 1977, physicists Baidyanath Misra and George Sudarshan described something that sounds like it shouldn't be possible. Watch an unstable quantum system frequently enough, and in the ideal limit, its decay can be frozen entirely. In practice, experiments show something slightly short of that, decay strongly suppressed, not slowed in the ordinary sense. In 1990, a team including Wayne Itano confirmed it directly, using trapped ions. Frequent measurement, exactly as predicted, suppressed the transition they were watching. Physicists named the whole effect after Zeno, the philosopher famous for arguing that motion itself might be an illusion. One necessary caution: there's a mirror effect, the anti-Zeno effect, where frequent measurement can accelerate decay instead. Watching doesn't universally freeze anything. It depends entirely on how, and how often, you watch. Centuries earlier, Patanjali's Yoga Sutras described a practice called dhyana, sustained, continuous attention on a single object, described as a state that can be maintained, held, through the quality of attention itself. Nobody is claiming Patanjali anticipated quantum measurement theory. The parallel is narrower. Both describe attention, sustained continuously, as something that changes what would otherwise unfold on its own. Investigation 5 asks the sharpest question of the 5. Can an unknown quantum state ever be copied? Exactly. Perfectly. The proof itself has an unusual origin story. A physicist named Nick Herbert had proposed a device, nicknamed Flash, that would use cloned quantum states to send signals faster than light. Asked to referee the paper, physicist Asher Perez found the flaw. The device required copying an unknown state, which turned out to be impossible. In 1982, Wouters and Zurich, and independently DX, turned that flaw into a full proof, not an engineering limit, a mathematical consequence of quantum linearity itself. Any device that copies one unknown state perfectly would break the mathematics for another. One necessary precision, learned the hard way. This theorem applies to arbitrary, unknown quantum states. Ordinary classical information, the kind in this sentence, copies just fine. Centuries earlier, the Bhagavad Gita and the Upanishads had described the Atman, the self, as indivisible, not copyable, not able to be cut or divided into parts. Here's the correction worth naming directly. Those texts never once mention copying. They describe indivisibility. The parallel to a no-cloning theorem is drawn here, by this investigation, using their logic as the bridge. It is not something the texts themselves claim. 5 investigations. Lay them side by side. What is a measurement? Bohr said. A physical interaction, nothing more mystical required. What if the measurer is quantum too? Proyetti's experiment, using photons standing in for human observers, said, 2 consistent accounts, neither simply wrong. Is the unmeasured world real and shared? D'Espagnat said, real, but veiled. Its deepest structure never directly reachable. Can watching hold a state in place? Misra and Sudarshan said, yes and no, entirely depending on how you watch. Can a state ever be copied? Wouters and Zurich said, never, not even in principle, for anything genuinely unknown. 5 different questions, 5 different, careful, qualified answers. None of them the same discovery, wearing a different coat. 5 separate investigations, using different apparatus, run by different people, decades apart. And yet, something recurs. Every one of these investigations refuses a comfort most people carry without noticing, that things simply have their properties, fixed and complete, waiting quietly to be checked. Interaction, in every one of these 5 cases, turns out to be doing more work than that comfortable picture allows. The 5 older investigations refuse something adjacent. In their own vocabulary, Nagarjuna, nothing stands alone, apart from what it depends on. The Mandukya. Beneath every account, there's a ground where no single account exhausts. Patanjali. Sustained attention itself changes what unfolds. The Gita. Something in you resists being divided into parts. Despagnat's veiled reality sits slightly apart from the other 4 here, and that's worth stating plainly rather than blurring over. He reached his conclusion from inside physics alone, explicitly without drawing on any of these traditions. His inclusion in this list isn't a 6th parallel. It's a modern investigation that, on its own terms, arrived at a structurally similar caution. Some part of the answer may simply not be available to direct inspection, however carefully you look. Try something adjacent to all 5, directly, for a moment, not as belief, as something to notice. Think of anything you're certain about right now, something you'd say simply is a certain way, full stop, your own mood, a relationship, your health. Now notice how much of that certainty depends on when you last checked and how. A mood measured at 7 a.m. is not the same measurement as one taken at midnight. Neither is wrong. Both are real, in their moment, shaped by the asking as much as by what's being asked about. That's not proof of anything these 5 investigations found. It's a small, personal echo of the same shape they kept finding at every scale they looked. Nothing here is being offered as one unified answer. Physicists still disagree about interpretation. Contemplative traditions differ sharply among themselves about what their own texts actually establish. Nobody solved anything by placing 5 investigations side by side. What's actually here is narrower and more honest. 5 careful investigations, decades and sometimes centuries apart, kept finding that the moment of interaction carries more weight than intuition expects. And 5 older investigations, working in entirely different territory, kept refusing the same easy comfort in their own language. None of this is finished. Physicists are still building new versions of these experiments, at larger scales, with more entangled particles, looking for exactly where, if anywhere, this pattern finally breaks down. That search is still open, right now, in laboratories doing exactly this work. A sealed room, a cloud of atoms, watched into stillness. A theorem that closes a door physics never expected to find closed. A physicist, honored for arguing reality, wears a veil. And 5 older investigations, in Sanskrit, in Pali, in temple libraries and forest schools, that got there first, in their own language, refusing the same simple comfort. Ancient wisdom, quantum mystery, direct knowing, this quantum gnosis,